NEC 2005 does not specifically mandate that the main disconnect in an industrial control panel be mechanically or electrically interlocked. However, NFPA 79, as stated, does contain this requirement. Regarding the short circuit current rating, or SCCR, NEC 2005 does not specify a specific SCCR rating for industrial control panels. However, it does require that the SCCR rating be marked on the panel if it has been determined. NEC Section 409.4 from the 2005 edition requires that enclosed control equipment that contains fuses or circuit breakers used as service equipment be labeled or marked with its SCCR rating. NFPA 79 Section 6.23 requires that the main disconnecting means be interlocked with any electrically operated switch that can re-energize the system, such as a transfer switch. NFPA 79 Section 5.3.1.4 requires that the main disconnecting means be mechanically or electrically interlocked with any access door that could allow contact with live parts. In summary, while NEC 2005 does not specifically require the main disconnect in an industrial control panel to be interlocked, it is generally accepted that NFPA 79 requirements should be followed for safety. Additionally, NEC 2005 requires the SCCR rating to be marked on the panel if it has been determined, but it does not specify a specific rating. Now, to further elaborate on these points, let's consider the practical implications. Firstly, the absence of a specific interlocking requirement in NEC 2005 for the main disconnect doesn't imply that interlocking is unnecessary. It simply means that the NEC, in this particular edition, defers to other standards, specifically NFPA 79, for detailed requirements on industrial machinery. The purpose of interlocking is to enhance safety by preventing accidental energization of equipment during maintenance or when access doors are open. This is crucial for protecting personnel from electrical hazards. The NFPA 79 standard provides specific guidelines on how to implement interlocking mechanisms, whether mechanical or electrical, to achieve the safety objective. Secondly, the SCCR is a critical parameter for industrial control panels. It indicates the panel's ability to withstand a short-circuit fault current without causing catastrophic failure. While NEC 2005 doesn't specify a mandatory SCCR value, it emphasizes the importance of determining and marking the SCCR on the panel. This is essential for ensuring that the panel is properly protected by upstream of current protective devices such as fuses or circuit breakers. The process of determining the SCCR involves evaluating the short-circuit current withstand ratings of all the components within the control panel, including the incoming circuit breaker or fuse disconnect, the motor starters, contactors, and other devices. The lowest SCCR rating among these components becomes the overall SCCR rating of the panel. This rating must be higher than the available fault current at the panel's location to prevent equipment damage or failure during a short-circuit event. Here's a more detailed explanation of the key concepts. Firstly, main disconnect interlock requirements. The main disconnect is the primary means of de-energizing the control panel for maintenance or emergency situations. Interlocking ensures that the disconnect cannot be switched on while the panel is being accessed or while certain internal components are energized. Mechanical interlocks typically involve physical barriers or linkages that prevent the disconnect from being operated unless certain conditions are met, such as the access door being closed. Electrical interlocks use sensors and control circuits to monitor the status of the access door or internal components and prevent the disconnect from being energized if unsafe conditions exist. NFPA 79 provides detailed specifications for these interlocking mechanisms to ensure their reliability and effectiveness. Secondly, SCCR rating and determination. The SCCR of an industrial control panel is determined by evaluating the individual SCCR ratings of its components. Each component, such as a circuit breaker, fuse, motor starter, or contactor, has a specified SCCR that indicates the maximum short-circuit current it can safely withstand. The overall SCCR of the panel is limited by the lowest SCCR rating among its components. To determine the SCCR of the panel, you must identify the component with the lowest SCCR rating. This rating becomes the SCCR of the entire panel. It is important to note that the SCCR of the panel must be greater than or equal to the available fault current at the panel's location. The available fault current is the maximum short-circuit current that the electrical system can deliver at the point where the panel is connected. If the SCCR of the panel is lower than the available fault current, the panel may be damaged or destroyed during a short-circuit event. Thirdly, NEC 409.4 requirements. NEC section 409.4, as mentioned, requires that enclosed control equipment containing fuses or circuit breakers used as service equipment be marked with its SCCR rating. This marking must be clearly visible and easily accessible so that electrical workers can quickly determine the SCCR of the panel. The marking typically includes the SCCR value in amps or kiloamps, as well as the voltage rating. The purpose of this requirement is to ensure that electrical workers are aware of the panel's SCCR and can take appropriate precautions to prevent short-circuit hazards. Fourthly, NFPA 79 interlocking requirements. NFPA 79, as noted, contains specific requirements for interlocking the main disconnecting means with electrically operated switches and access doors. Section 6.23 requires that the main disconnecting means be interlocked with any electrically operated switch that can re-energize the system. This prevents accidental re-energization of the system while maintenance is being performed. Section 5.3.1.4 requires that the main disconnecting means be mechanically or electrically interlocked with any access door that could allow contact with live parts. This prevents personnel from accessing live parts while the panel is energized. These interlocking requirements are essential for protecting personnel from electrical shock and arc flash hazards. Fifthly, importance of following NFPA 79. While NEC 2005 does not explicitly require interlocking of the main disconnect, it is generally accepted that NFPA 79 requirements should be followed for safety reasons. NFPA 79 is a comprehensive standard that addresses the electrical safety of industrial machinery. It provides detailed guidelines for the design, construction, and installation of electrical equipment in industrial environments. Following NFPA 79 helps to ensure that industrial control panels are designed and installed in a safe and reliable manner. In conclusion, while NEC 2005 may not explicitly mandate interlocking of the main disconnect in an industrial control panel or specify a particular SCCR rating, it is crucial to adhere to NFPA 79 for detailed interlocking requirements and to ensure the SCCR rating is marked on the panel if it has been determined. These measures are essential for ensuring the safety of personnel and equipment in industrial settings. It's worth noting that electrical codes and standards are constantly evolving to reflect new technologies and best practices. Subsequent editions of the NEC and NFPA 79 may have updated requirements regarding interlocking and SCCR ratings. Therefore, it's always important to consult the latest versions of these standards to ensure compliance. Now let's delve deeper into some specific aspects of industrial control panel design and safety. Firstly, regarding the types of interlocks, mechanical interlocks are a simple and reliable way to prevent accidental energization. They typically involve physical barriers or linkages that prevent the disconnect from being operated unless certain conditions are met. For example, a mechanical interlock may prevent the access door from being opened unless the main disconnect is in the off position. Electrical interlocks offer more flexibility and can be used to monitor a wider range of conditions. They typically involve sensors, control circuits, and relays that prevent the disconnect from being energized if unsafe conditions exist. For example, an electrical interlock may monitor the voltage level of internal components and prevent the disconnect from being energized if voltage is present. Secondly, about SCCR calculation, determining the SCCR of an industrial control panel can be a complex process, especially for panels with a large number of components. There are several methods for determining the SCCR, including component-by-component evaluation, series rating, and the use of listed and labeled assemblies. Component-by-component evaluation involves determining the SCCR of each individual component in a panel and then selecting the lowest rating as the overall SCCR of the panel. Series rating involves using overcurrent protective devices in series to increase the overall SCCR of the system. Listed and labeled assemblies are pre-engineered and tested assemblies that have a specified SCCR rating. Thirdly, short-circuit studies. To ensure that the SCCR of an industrial control panel is adequate for the available fault current at its location, it is important to conduct a short-circuit study. A short-circuit study is an engineering analysis that determines the magnitude of the fault current that would flow during a short-circuit event. The results of the short-circuit study can be used to select overcurrent protective devices with adequate interrupting ratings and to verify that the SCCR of the control panel is sufficient. Fourthly, arc flash hazard analysis. In addition to short-circuit studies, it is also important to conduct an arc flash hazard analysis. An arc flash is a dangerous electrical explosion that can occur during a short-circuit event. An arc flash hazard analysis determines the potential arc flash energy that could be released during a short circuit and provides recommendations for reducing the risk of arc flash injuries. These recommendations may include the use of personal protective equipment such as arc-rated clothing and face shields, as well as the implementation of engineering controls such as arc flash barriers and remote racking systems. Fifthly, documentation and labeling. Proper documentation and labeling are essential for ensuring the safety and reliability of industrial control panels. The panel should be clearly labeled with its SCCR rating, voltage rating, and other important information. The panel should also be accompanied by detailed documentation, including wiring diagrams, component lists, and operating instructions. This documentation should be readily available to electrical workers who are responsible for maintaining and troubleshooting the panel. Now, let's address some common questions and misconceptions about industrial control panels. Firstly, is interlocking always required? While NEC 2005 does not explicitly require interlocking of the main disconnect, it is generally accepted that NFPA 79 requirements should be followed for safety reasons. Interlocking is especially important in situations where there is a risk of personnel contacting live parts or where accidental energization could cause equipment damage or injury. Secondly, what is the difference between SCCR and interrupting rating? The SCCR is the short-circuit current withstand rating of a component or assembly, while the interrupting rating is the maximum short-circuit current that an overcurrent protective device, such as a circuit breaker or fuse, can safely interrupt. The SCCR indicates the component's ability to withstand a short-circuit event, while the interrupting rating indicates the overcurrent protective device's ability to clear a short-circuit event. Thirdly, can the SCCR of a panel be increased? The SCCR of a panel can be increased by using components with higher SCCR ratings, by using overcurrent protective devices in series, or by using listed and labeled assemblies. However, it is important to carefully evaluate the impact of these changes on the overall performance and safety of the panel. Fourthly, what are the consequences of exceeding the SCCR? If the SCCR of a panel is exceeded during a short-circuit event, the panel may be damaged or destroyed. This can result in equipment downtime, property damage, and potential injuries to personnel. Fifthly, how often should industrial control panels be inspected? Industrial control panels should be inspected regularly to ensure that they are in good condition and that all safety features are functioning properly. The frequency of inspection should be based on the operating environment, the age of the equipment, and the manufacturer's recommendations. In summary, industrial control panels are complex and critical components of industrial electrical systems. Proper design, installation, and maintenance are essential for ensuring the safety of personnel and equipment. By following the requirements of the NEC and NFPA 79, and by conducting regular inspections and maintenance, you can help to minimize the risk of electrical hazards and ensure the reliable operation of your industrial control panels. Remember to consult with qualified electrical professionals for specific guidance on your particular application. Codes and standards can be complex, and it's important to have a thorough understanding of the requirements before making any changes to your electrical system. And always prioritize safety when working with electrical equipment.